My name is Vanessa Little. I am the Director of Telco Innovation over at VMware, and I lead the team that deals with a lot of open source integrations, particularly for telco and the VMware vCloud NFV stack. So I'm going to talk to you today about open source telco orchestrators. What's the big deal? What's happening in this space? Where's it been and where's it going? And then we'll have a little time at the end for some Q&A. So the first question everyone needs to ask themselves is, why even bother with orchestration at all? And there are a few very important and fundamental answers to that. The first one is networks are getting more and more complex. As telcos are virtualizing their networks, they're noticing that there are a lot of different touch points that they need to not only touch when you deploy a network service, but also keep track of once that network service is running. It's becoming untenable to do this with just humans or with tools that are in market today. Basic monitoring, SNMP monitoring systems. We need to have the concept of an orchestrator that understands the topology of what's deployed, as well as how well it's functioning, in order to do this at any sense of scale. And I'm going to talk a bit about what happens when you start deploying 5G networks and edge networks, and you have all these different disparate systems all over the country, all over the world that you now need to maintain. It's no longer feasible to do it with traditional tools and methods. The second key reason is telcos are looking to reduce their time to market. If a telco could deploy a new service inside of 6 months, that used to be amazing. And now the bar is set much higher. Now we're looking at getting new services to weeks in a matter of months or even days. And that timeline is shrinking so that new services can be modeled and deployed and tested much more rapidly than they were traditionally. And all of this is sort of the promise of NFV and sort of the promise of virtualizing your telco cloud. The whole goal was to be able to not rely on specific appliance-based hardware vendors to deploy your network service, but be able to do it all in software and have it be as flexible as you wanted it to be. None of this is even possible or achievable without the concept of orchestration. And so for the past 3 or 4 years, a lot of different initiatives have popped up to really address this problem. As I mentioned, the network complexity is accelerating. When we start looking at edge computing and pushing those workloads out closer to the edge to reduce latency, this means we now have many more data centers. Where we traditionally had 3 or 4 different core data centers with a few DR data centers, now we're looking at having more infrastructure in the aggregation sites and even more infrastructure right down to the edge. It's no longer just about the radio access network. Now telcos are looking at pushing compute capacity right down to that edge to have the lowest latency possible. But now what you've done is you've spun up all these different data centers that you now need to maintain. And now you need to start thinking about things like intelligent workload placement. Where is it that I want to push this particular network service? Which of these data centers does it need to touch? Et cetera, et cetera. This isn't something that you could do manually just by putting a human in a chair in front of a console. So some interesting stats about the rise of 5G networks and where the networks are going. By 2025, 100% of new cars will be connected. What we're seeing now is not only are things being built on board in the cars where they're all connected to cellular networks, but they're also building systems where they can send real-time telemetry back to the car manufacturer and tell them things like the engine is starting to stutter in piston 6. And so you might want to book an appointment with your mechanic to get it sorted out. This is a lot of data that's starting to flow back. When we look at connected cars where they're having constant conversations with each other, and collision avoidance is no longer going to be contained specifically in the car. It's going to be a matter of having a conversation with other vehicles that are on the road so that you can do things like intelligent traffic shaping. All of this data has to flow somewhere. All of this data has to be maintained somewhere. And so all the applications that are going to be manipulating and managing this data are going to be deployed at the edge, at the aggregation sites, et cetera, et cetera. Being able to manage this new generation of applications is much more of a cloud function than it is a telco function. And so adopting these cloud methodologies that have been in place for maybe the last 15 years are really becoming more relevant to telcos as they move forward into these more complex networks. By 2025, approximately 200,000 remote surgeries will be performed in the US alone. You need very stable, very robust networks to do this. Latency can't be a factor, jitter can't be a factor, packet loss can't be a factor when you're manipulating a robot that is inside someone's body. More than ever before, network resiliency is extremely important. And when you're looking at complex applications like this sitting on top of those complex networks, orchestration is a no-brainer. And the other use case that's really relevant right now is, right now, the average nationally is 14.5 minutes for a priority 1 response time. So calling 911, between the time you make the call and someone arriving to assist you, that's 14.5 minutes. When you're actually enduring an emergency situation, this is a lifetime. And so a lot of these applications that are being pushed near the edge, a lot of these IoT applications, things like Smart City, where they're starting to do license plate recognition, video analytics that will start detecting things like crowd convergence, explosion detection, shots fired, audio analytics. All of these applications are pretty complex, use some pretty heavy compute, and need to exist closer to the edge in order to be effective in real time. In order to get this 14.5 minutes down, we need to start removing that human element of calling someone and saying, please come help me, and having that push more to automated systems that say, I detect an emergency in this area of the city, somebody look at this. So when you look at, so now that we've really established why orchestration is going to be necessary going forward and becoming increasingly more necessary, we need to ask ourselves, is open source really the answer? Because we're looking at things that are so mission critical, things that absolutely cannot fail, is open source going to do it for us? And so I've made a little pro-con list here to talk about that. So some of the pros of open source, it's led by community-driven requirements. And so the things that you need the software to do today are what gets built in right away. And it's the largest demand drives what features are going into the product set, and that's great. It gives you an ability to stay vendor agnostic and integrate what's needed when it's needed. So when you're looking at all of these northbound, southbound integration points, even the east-west integration points, the things that are relevant to the contributors are what are going to get built in, not whatever a vendor wants to sell you. Some of the cons are that community development can be difficult to manage. There's a lot of open source communities that live and die without ever really achieving proper adoption or success. You need to be able to drive people that want to contribute code to your community. You need to be able to keep those people interested and keep that community viable by not only bringing in people from the consumer area, the people that are actually going to use the software, as well as commercial software vendors that want to make sure that they have compatibility and interoperability with what you're building. And so it's a difficult thing to manage. Only a few open source projects ever really achieve that type of long-term success. And so it's a bit of a risk early on. But once you have a little bit of traction, it's actually a huge benefit. And finally, the lack of commercial support. Telcos traditionally offer SLAs to their customers. They want to be able to guarantee a certain level of service. And so if any of the components in their infrastructure break, they need somebody to call to say, get down here and fix this. With open source software, that paradigm is shifting. And that traditional model of having a vendor that you pay to be at your beck and call is no longer the model that's working. And I'll talk a little bit about the models that do work. On the commercial side, the pros are you have a fully supported solution that's pre-tested, pre-integrated. You know where the bugs are. You know where all the bodies are buried. You know exactly how it's going to behave. The company that provides this software has done a lot of testing and provides a lot of metrics and documentation about exactly how it's expected to work, and that's great. Some of the cons are that the commercial solutions are going to be more effective with the other things that vendor provides. So in the case of telco orchestrators, the orchestrators that are more commercial are going to be really effective with the VNFs that they will give you, not as effective with the VNFs that other people provide because they want to push you toward buying more of their products. If If you want to integrate any kind of changes or do customizations or integrations with other systems like OSS, BSS, Northbound, for example, this usually requires some pretty costly professional services, and it's a pretty lengthy exchange. I think a lot of telcos have suffered that in recent years. And finally, the VIM and the VNF and the infrastructure options are pretty limited. There's the concept of vendor lock-in, and that the software's only been tested and integrated with a certain subset of things that they can guarantee is going to work. If you want something that's going to work, you're limited as to what you can actually deploy. And so that's obviously a huge downside that's really led to the rise of some of these open source orchestration products. One of the other challenges in what's currently happening in the community is this war with the data models. Should my data model be Tosca? Should my data model be Yang? Tosca traditionally comes from a more cloud-based approach and was originally embraced by CI/CD and DevOps clouds to help automate those deployments. And it's very well-versed in cloud technologies, not as well-versed in network technologies. And so successful deployments of Tosca models have had to extend those models outside of what's currently standardized in order to be effective in a telco cloud. Then on the other side, we have the Yang models. These are They have their roots in network infrastructure and network development, and so they're very good at describing network architectures, network designs, and being able to maintain a network. Not so great at maintaining clouds. And so it's really the intersection of the two that's really the happy medium. And what we're seeing now today is it's not mattering as much whether you like your modeling in Tosca or Yang. And what we're seeing people doing is taking a Tosca wrapper that has embedded Yang models for the network components so that they're able to construct and maintain those really effectively. But the cloud components and the virtual machine components and the stuff that touches the VIM, that's all described in Tosca, and you can stack them all together in sort of a hybrid model language. More and more orchestrators are starting to support this going forward. And I think personally that's really the best way to go. Is there are so many different components in your network that are traditionally maintained with different means. Some of them are netconf, some of them you can still reconfigure with SNMP. They all have different proprietary ways of doing it. So instead of pushing a new paradigm onto the community and saying, everybody must write models in Tosca, it's much easier to say, here's a wrapper, send me what you've got, we'll encapsulate it, and make a plugin to make it work. That's going to drive adoption a lot faster than trying to push yet another model onto everybody, because everyone's waiting to see how this shakes out. I don't think there will be one clear winner. The winner is going to be a compromise between what people currently have and what they need to really describe what's happening in a telco cloud. And then we need to talk about what I call the elephant in the network. A lot of orchestration projects have sort of stumbled in recent years trying to address the fact that VNFs are very poorly written. Virtualized network functions came into being by companies taking what used to run on a very specialized physical appliance and sticking it in a VM. Just doing like a straight P2V virtualization of something that used to run on very specialized hardware. And then these vendors start complaining that it runs badly in the cloud. Well, no kidding. So then they start doing things like, well, I need to do PCI pass-through to make this run well. I demand SRIOV. I demand to touch the hardware. I need SmartNICs. I need to accelerate this. I need to do this and that. And what they're effectively doing is violating the core tenets of why you're in a cloud in the first place. They're really removing why you're trying to virtualize at all. You might as well have stayed on your physical appliance, because now you've pinned yourself so hard to that piece of hardware. You can't migrate that workload anywhere elegantly. You can't scale it in elegantly. You can't scale it out elegantly. So what orchestrators did was they tried to take this problem onto themselves and say, okay, all these EPA settings, I'll let you set those. All these migration settings, well, I'll find a way to compensate for that. Oh, and I'll give you a little spot to put scripts that'll let you manually mitigate the fact that you wrote some crappy software. And so now the industry is finally pushing back on the VNF vendors and saying, okay. Make your software more cloudy or no one's going to buy it. And we're especially seeing this now that Kubernetes is becoming more and more of a factor, and edge deployments are becoming more and more of a factor. People want to have very small, very volatile deployments at the edge, and that requires software that is stateless It requires software that scales out very well and it's easily monitored. And it's not like these technologies are new. People have been doing this on the IT side of the house for years. Like look at how LAMP stacks are deployed. Look at how CI/CD pipelines are constructed right now. You have all of that beautiful manipulation happening already on the IT side of the house. So now it's time for the software vendors on the network side of the house to wake up and realize that they're in a cloud. And it's no longer the responsibility of the orchestrator to compensate for that. So what we're seeing now, and I think this shouldn't be news to anybody at this conference, but the life cycle of successful open source is the project inception. So that's when a few very intelligent people get together and say, here's an unmet need, here's a gap, and I think that we can write some software that's going to address that. And then there's adoption where a bunch of other people say, you know what, that's a great idea, I want to help. And you start getting more contributors, you start getting commercial contributors, larger companies that have deeper pockets that are able to put 5 or 6 devs on it. And then you see the project grow, the code base grow, it gets a little more maturity and it starts to get a little bit better code hygiene, and it becomes a real living, breathing project. And then finally, the really successful projects like OpenStack are commercialized. You start seeing companies that will either fork a copy of what's currently in upstream and provide commercial support on that, or provide, and what we're seeing more and more now is provide commercial support on what's currently in the upstream code base. This is a great trend for open source software, the fact that we can now have the best of both worlds, where companies that need that one throat to choke, or they need somebody to call for help, they can now get it with the flexibility of open source software. So all the benefits of open source, where you have community-driven development and you can drive new features in when you need them, combined with getting someone to call when it breaks, this is what we were all hoping for. And we're finally starting to see this be more prevalent in the telco space, and particularly with telco orchestration. So this is a great trend. So who are these unicorns that are popping up to support these open source projects? It's 2 main vendors. System integrators. So these are companies that are particularly services led. They'll look at requirements for a network infrastructure and build this company's orchestrator with this company's Vim, with this company's VNFs, all integrated together, and they will offer support on that as a full stack. And it's built as sort of a customized environment for that particular customer. There are system integrators globally now that are doing this. And secondly, there's the software vendors who participate in the upstream projects. They actively contribute code, and then they will offer support contracts. Sometimes it's on a time and materials basis for how much you want to manipulate the code, or sometimes it's just you want someone to call to help you install it and maintain it. So the intersection of the two, sometimes there's a bit of overlap and some collaboration there, but these 2 types of companies are really stepping in and stepping up to be able to offer proper support contracts on open source orchestration. So who are the big players in open source orchestration right now? There are more projects than I've encapsulated here, and if anyone is leading any of those projects, I don't want to offend you, but I just want to focus on the top 4 here, because we could probably talk for days about the orchestrators that are available. But these are the 4 that are the most prevalent in the market today. These are the ones that have the most traction and the most activity. And that's ONAP, OSM, Cloudify, and Rift. And we're going to dig a little deeper into what each of these projects are. So ONAP is a Linux Foundation project. I think everyone in this room has heard of this project. It has excellent marketing. It was founded in 2017, and it started as an initiative between AT&T and China Mobile. If anyone remembers, it was the consolidation of OpenO and OpenEComp. So now that's become ONAP. The core focus of this project is really more OSS-BSS integration and sort of building that framework to start stitching together all of those disparate systems in a telco that really comprise a network service, and being able to provision and maintain a network service. So things like fulfillment, billing, lifecycle management, all of these things needed hooks into your network service. it's not just a matter of being able to deploy a network service and touch your Vim and your SDN layer, but how does that actually work in your business? And so this project really provides a great framework for that northbound integration of all of these disparate systems. Open source Mano has more of a focused area that they're looking at. This project was founded in 2016 and was launched at Mobile World Congress that year, and was really the conglomeration of Telefonica, BT, Telenor, and Sprint. Those are the operators that came together that came up with this project. It was initially spawned as a means of validating and ratifying the ETSI standards in NFV and orchestration. ETSI kept publishing all of these standards for NFV, all these IFA models, all these SOL models. No one was actually using them because no one knew if they were viable, if they'd work. So this project initially spun up to say, okay, we're going to consume some of these models insofar as we can. A lot of them are still works in progress. We're going to consume these models, we're going to build an orchestrator, and then we're going to let you know how it works. So that was the idea behind how it started. As the project moved along, what we discovered was the models were not always complete. And so most of the things, particularly things around data modeling and the information model, needed to be extended to encapsulate different types of things that no one had really thought of. And so the result of this project was really that it developed a really elegant feedback loop back into the ETSI standards community to say, these are the standards that we were able to consume and they're great. These are the ones that we need to add back into those models. So please put these back into the IFA models, put them into the SOL models. These are the things that we didn't use because we think they're irrelevant. And then here's the other set, and these ones are a little more contentious. These are the ones that we think you need to change. So it's a great vehicle to ratify those standards and really validate those standards, and I think it's working well. But OSM's core focus is really with controlling the infrastructure. So while it has a northbound interface to do that OSS-BSS integration, the whole concepts of things like fulfillment and billing don't exist in OSM. And it's not concerned with that sort of thing. It's concerned with deploying and maintaining a network service. So it's really like that Vim and SDN layer down, where ONAP does have that feature, but their core focus is really more upward in being able to integrate northbound. So a lot of people talk about, wouldn't it be nice if we had an architecture where we have ONAP across the north side, and then we have OSM as one of the Vim managers. And it's completely possible. I think it's actually been done in a few labs right now. But as the projects move forward and as those north and southbound APIs get a little more firm, it's completely possible to do that for anyone who would like to. And now that everyone's starting to rally around common data models, it's totally possible to do this with minimal manipulation. Then we have sort of a different class of open source orchestrators. And Cloudify is one of those. They were founded in 2012. And they come from the cloud, the IT cloud side of the house. So they do cloud manipulation really well. Initially, some of their gaps were more around understanding some of those more difficult network concepts and why you'd want to do things that are a little more intricate than just a standard layer 2 network. I think their product has come along significantly since then, and they're doing some really interesting things with tiered networking and being able to put subsets of their orchestrator and small little pockets of orchestration further down in your network. So now that you have that tiered network with the core data center, the aggregation site, and the various edge sites, being able to push some of those orchestration capabilities a little further south into closer to the edge so that the edges are a little more self-sufficient. These are things that Cloudify is really looking at now, and I think it's pretty necessary because as the networks get more complex and wider, having one centralized orchestrator that rules them all isn't really tenable, and it doesn't really make sense either. You don't necessarily need something that has this God's eye view of your entire network infrastructure right down to the last CPU. It doesn't make sense. Being able to have little pockets that have a great view of what's local and then rolling a summary up northbound does make a lot of sense. And that's really what Cloudify is working on lately, and it's pretty interesting stuff. And then finally, there's Rift. So this is another one of those open source software that offer a commercial paid version that they can support. And so these guys started in 2013. The DNA of this company comes more from the network side of the house. So these guys really understand network architecture, network design, how to manipulate network devices, how to reconfigure things that are running services, and how to monitor and maintain them. Their initial gap was more on the cloud side, and how to deal with virtualized infrastructure, how to interface well with Vim and that SDN layer. And they've since shored that gap up. So it was really interesting to see those two companies that kind of came into being around the same time. One came from the cloud side, one came from the network side of the house, and they both sort of shored up their gaps to meet in the middle to have very similar functionality. Rift is a US-based company, and they do have some commercial success, but across all of these open source orchestrators, you don't see any that are in full production in a huge capacity in any tier 1 networks today. They're all still considered somewhat works in progress. Even though most of them can be commercially supported now, even though their code base is considered robust enough to be production grade and carrier grade, no one's really taken that leap of faith yet to deploy it at any real scale. So looking back on what's been accomplished in open source orchestration, I've kind of divided it into 4 or 5 core themes. Stability and deployment ease. There's been a lot of work done here to make it easier to install these orchestrators and configure them and keep them running. If anyone tried to install, for example, the first version, the first release of ONAP, my hat's off to you, because that probably took a long time and resulted in a lot of heads beating on desks. Now, all these orchestrators are very easy to install. Most of them are containerized, so you can just download something from Docker Hub and you have a running orchestrator in under 5 minutes. Another thing that they've really started to step into is this concept of service assurance, and the fact that the orchestrator is not just responsible for that day 0 deployment and getting your network service out there, but it's also responsible for the life cycle and maintaining the health of that network service. And so integrations with things like monitoring systems, alerting systems, management systems, so that you can start overlaying that concept of, here's my network topology and here's how well it's functioning, what do I do about it? The orchestrator is in the best position in your network to do that. And so all of these orchestrators have started to build more robust hooks and start to put KPIs directly into their data models, so that when you build a network service and you deploy a network service, you say, here's my network service, and here's how I monitor it. These are the thresholds that are important to me. And those are going to be different for every deployment. Those aren't necessarily universally true. I think when people started addressing this, they said, well, if I just know, I'm going to use my traditional monitoring tools, so if I know if the CPU is going 90%, if I know that this NIC is saturated, then I can probably guess that my network service is not healthy, but that's not necessarily true. The concept of determining service health is actually pretty complex. And so instead of bringing all of that telemetry management and root cause analysis into the orchestrator, now what we're seeing are just API hooks into systems that do that stuff really well. And going forward, I think we're going to see even more of that, because I think a few orchestrators initially said, okay, send me all of your telemetry. I'll deal with it. And so we were sending, all of these messages, all of this polling, all of this constant telemetry. And now the orchestrator became a service assurance and a monitoring platform. And that's crazy, because what you've done is you've taken something that had a very specific purpose and bolted on an even bigger purpose to try to make that little thing work better. And it didn't make sense. So now the orchestrators are kind of doing a bit of a reset, pushing that back out to people that do that well, pieces of code that do that well, and just building an interface in. Say, okay, send me the alerts when something relevant happens. Send me an alert when the service is actually down, or when it's no longer functional. And then the orchestrator can then remediate that. Orchestrators are now starting to look at things like, how do I orchestrate to the edge? How do I handle things like intelligent workload placement? And initially, this just became things like, well, I have a couple availability zones, so I'll just put this VM over there. And it was very basic and very simple. But it fulfilled the need in being able to, even those simplistic implementations fulfilled the need to be able to say, I want to put my workload there and not here. And we're seeing a lot more stuff happening in that space going forward, and we're going to see a lot more granularity around intelligent workload placement and being able to make decisions around workload placement that don't necessarily have to do with geography. Things like hardware requirements. I need to deploy this workload on a device that has a GPU. So where do I have GPUs? Well, the orchestrator needs to know that before it can make a decision about where to put it. There's been a lot of work done around multi-site definitions and this concept of, I have more than one Vim available. There's no telco in the world that only has one Vim installed. They all have many, and they all have different purposes. And having an orchestrator that can roll up and see all of them and orchestrate across all of them and start to build network services that might span more than one Vim are capabilities that have recently been built in orchestration in its most basic form. And we're seeing that move forward a lot more in the coming year. And finally, the concept of service function chaining. It's a newer-ish development in the VIMs and that capability in some of the SDN layers. And so the open source orchestrators really embraced that and said, oh, finally we can do service function chaining. Somebody implemented it. And so orchestrators immediately built into their data models the means for defining that as a network service and being able to use that. There's still a lot of gaps there in how those chains can be manipulated and how they're managed. But the idea that the framework is there and the fundamentals are there is actually really positive. So things that we're looking to in the near and further out future, standardized integration points. The standards are finally having a positive impact. The ETSI SOL models and TM Forum northbound APIs are pretty much the de facto standard now. It's either a SOL 5 northbound API, or it's a TM Forum northbound API, or it's both. People are really rallying around those two. And so having standardized northbound interfaces is awesome, because now we have the capability to integrate some of these northbound OSS, BSS systems, and it can be pretty agnostic, and you can have your choice of orchestrator without having to do specific integrations with each one. If everybody's SOL 5 compliant, test with this orchestrator, test with that orchestrator, maybe have both of them in your infrastructure. It might make sense to do so because different orchestrators have different capabilities. Being able to have that choice blown open because they've all standardized on a common northbound API is really powerful. And that's exactly where they're going. The communities are really rallying around that SOL 001 data model. This is a Tosca-based data model. But almost all of the big four, except one, currently support it, and that one is shoring it up. So having a common data model, it really takes away all of that pain that we had with being able to build network service descriptors for the different orchestrators. There have been a few open source projects. I even ran one that was trying to be sort of a Rosetta Stone for all of these different types of network service descriptors. And it's not possible to do that and be able to translate between all of them a lot. Like, it's not a one-to-one relationship between all of the different objects. And so everybody rallying around one data model, even if it's not perfect, it's a very positive thing, because now everyone can influence that data model and extend it to add the gaps and fix the little problems and the gremlins in it, as opposed to everyone saying, well, forget you, I'm going to do my own thing. Now they're all starting to rally around one, which is good news. And the other standards that are really being embraced are SOL 002 and SOL 003, and this is how interactions with the VNFM are happening. One of the other trends and one of the naughty things that the VNF vendors did was a lot of them made proprietary VNFMs that had a very customized way of interfacing with it. Some of them had REST APIs that they made up. Some of them still respected netconf modeling to be manipulated. Some of them could be configured with SNMP. Some of them you had to SSH into and do command line stuff. They were all totally different. So integrating a VNFM with your orchestrator was next to impossible unless you wanted to take on the expense of doing a very complex one-off integration. So now everyone's starting to rally around these published standards to say, okay, I have a Sol2 REST interface, I have a Sol3 REST interface, so I can at least adhere to these core tenets. Some of them, they're still not going to abandon the secret sauce of their own specific northbound API or their own specific way of being configured. They're not going to throw that code base out, but at least they're starting to support the supported models so that it's a lot easier to integrate them with an orchestrator. Closed-loop service assurance is going to continue to be a pretty heavy area of development in open source orchestrators. Being able to define KPIs and metrics that determine service health and then monitor those, not necessarily inside the orchestrator, but have a system that talks to the orchestrator, that monitor those. And we'll see more integration with engines that are really clever at doing that. Almost every open source orchestrator now has a Prometheus integration. We're going to see more integrations with commercial vendors as commercial vendors step in and integrate with more complex root cause analysis systems, so that these orchestrators are now armed with a very powerful tool to say, here's my network service, but it's not running well, so I'm going to scale it out, or I'm going to reset it, or I'm going to migrate it to another facility. Being able to have the data to make those intelligent decisions has always been a gap in open source orchestration, so there's a lot of focus on that going forward. Hybrid and multi-site network services. People came to realize pretty quickly that a lot of network services don't necessarily live and die in one particular VM. They might span multiple VMs across multiple geographies in different data centers, and those VMs might not necessarily be the same version. They might not even be the same type. You could have a vCloud director and a KVM OpenStack that you want to span a network service that goes across them. That's kind of complex because of the stuff that's underneath. But now orchestrators are making that a lot more agnostic to say, I don't care what my VM is. I want a network service that spans here to here, that has the following function, that uses this software. Do what you must to make it happen. And so orchestrators are really taking that responsibility on to be able to integrate with those various VMs and have it be seamless, whether it's public cloud, private cloud. All the orchestrators have connectors into all of this stuff. And they're starting to build the models and the architecture to be able to have network services that span across these different VMs. And we're going to see more SDN features. There's always been this challenge around being able to marry what you need to do with your overlay SDN layer and some manipulations on your underlay SDN layer. And so, you've got these competing products like NSX and ODL that really have overlapping but completely disparate features and technologies, but you need an orchestrator that says, I need to do this to my underlay to facilitate this with my overlay. So if you want to have a more complex network architecture and being able to design and model that, that was always missing in open source orchestrators, in orchestration in general. But now those concepts are percolating into the open source orchestrators, and the extensions to the data model to make that possible to even design it are happening. So that's all I have to talk about today. I didn't do a time check, but do we have time for a few questions? If anyone has any questions about what we discussed today, or just comments or theories about orchestration in general. Anybody want to throw a few high fives or?
Thanks for highlighting the enhanced platform awareness chaos. How long do you think that's going to stay with us, or maybe it will age out?
I'm hoping it's going to age out in the next couple of years. That market's really driven by the consumers, and so we're seeing a lot more pressure coming from the carriers themselves, particularly the tier ones that have deeper pockets. They're starting to push back on that VNF community to say, I'm not buying your software unless you fix it. But that said, you can't rewrite these complex applications overnight. Just removing the whole concept of statefulness out of a telco application, like these things are, state personified. They need state to be able to function properly. So being able to rip those apart and make them into, cloud native and proper cloud applications, it's actually pretty difficult. So I'd say it's going to be at least 3 years before anybody's really successful. If they even bother for things like mobile core, I think mobile core is probably going to stay pretty static the way it currently is, and we're just going to deal with that pain because mobile cores are, it's one of those deploy it once and leave it kind of workloads. You might scale it out for capacity, but you don't go and redeploy your whole core every day. But some of these new 5G and IoT services, those are a lot easier to make cloud in. I think we're going to see a lot more traction in the services around what's coming next as opposed to trying to retrofit what's on the truck today.
Cool. Thank you.
Thank you.
First of all, thank you for providing this overview of it. And just from some of the telco perspective, as a bringer of applications, we have had that need to, we have pushed the orchestrators, for instance, to try to support those features so that we can get, VNFs onboarded. Do you feel like we're getting to more, at least a stable set of requirements for those VNFs, with those orchestrators?
Yeah, absolutely. I think in the beginning, what was thrown at the orchestration community was just I want the moon. Give me everything. I want to be able to manipulate all the stuff. I want to be able to magically touch all the things and have it all just work. And I think that ask was a little bit bananas. It was a little bit too much. And so now I think the ask is much more focused to say, this is what I want to achieve. This is what I want to do. Instead of saying, this is how I want you to write your code. And I think that's a really positive thing. So I think the orchestrators have a pretty clear view of what they need to do for the way VNFs are written today, as well as the way VNFs are going to be written tomorrow. It's a much clearer picture now, and where the gaps are pretty obvious. Whereas I think a couple years ago, everyone was just kind of winging it.
Thank you. I also see a lot of work needed in the service assurance area in the move that you're talking about for the orchestrator to get essentially high value actionable input back from the service assurance platforms. And the other aspect is we're living with the VNFs is the day 2 configurations. Where are they, right? How can they be recreated beyond just getting a VNF recreated, virtual machine recreated? So I know a lot of opportunities still for us to learn to do that better, but thank you.
Oh, no, thank you. You're absolutely right. You make a really valid point around the day 2 lifecycle management and being able to do things like push configuration to a running VNF. In cloud land, in the IT side of the house, this is really easy. You want to push a new config to your web server, you want to push a new config to your database, just do it. It works. The tools are there and they work fine. VNFs, on the other hand, are a little more rigid and they get a little brittle when you start doing that. And you have to do more complex manipulations like spin up another copy of that network service with the new config and then slowly swing the traffic over, because that's the way we used to do it when it was physical networks. And it's breaking that mentality and getting the capabilities built into the VNF software before we can really do that. Because the good news is the tools are there today when the VNFs can support it. In the meantime, we have to have this more complex migration strategy where we can define that as a separate network service and spin it up and manually push traffic over. We can still do it. It's just not very pretty, very inelegant. Anyone else? All right, well, thank you, everybody. Enjoy the rest of the conference.